Hello, students, and welcome back to our next lesson on lunar cycles. Yesterday, if you recall, we were talking about the features of the moon and the movement of the moon. Well, today we're going to pick it up where we left off, and we're going to be talking about phases of the moon. And the phases of the moon are directly related to how the moon moves relative to our position on the earth and the way the sun is shining on both the moon and the earth and our perception of it. So let's get right to the phases of the moon. And I've got a cool video I'm going to show you a little bit later on that really illustrates the phases of the moon from a perspective of outer space, so you can really see what's going on very well. So what are the phases of the moon? Well, they are a change to the moon's appearance. In other words, how we view it. Nothing really is changing on the moon, but the way we see the moon, the way it appears to us, is changing. And this is a direct result of, it is due to its orbit around the Earth. We talked briefly yesterday about how the moon revolves around the Earth and it rotates on its axis, and those periods of time are exactly the same. Well, because of those movements of the moon around the Earth, we get to see the moon from a different vantage point. And the lights went out there for a moment. Golly. But what we really want to see is the next slide. This illustration is actually in your book. And through this section of our notes, you're going to be filling in some blanks here. And what you're going to be doing is not only filling in what the moon and the Earth look like from the vantage point of space, but you're also going to be illustrating what the moon looks like as viewed from the Earth. And you're going to be naming the different phases as well. So there are three things you're going to be doing with this diagram in your book. And so let's get to it. All right. First, let's begin with a view from space. If you were an alien visiting our planet with the moon revolving around it, or if you were an astronaut, going straight up from the North Pole, this is what you might see. This is kind of a top view of the Earth and the moon over time, over the course of a month, revolving around the Earth. And the sun is presumed to be over to the left here in this diagram, and you can see these arrows indicating the direction of sunlight. So here's the first thing I'd like you to do. On your diagram in your book, I want you to notice the 8 different positions of the different phases of the moon and notice what you're going to be doing. In fact, look at this for a moment first. I have a ball here in my hands that I'm showing you on the screen. One side is white and one side is black. Now, if I were to rotate this so that you could see it from the top, in fact, I'm going to turn it all the way around here, okay? We could say that the sunlight is shining in this direction. So this side of the sphere is illuminated, and the other side of the sphere is in darkness. And viewed from the top, you can see that half of it is lit and half of it is dark. That's what you are going to be illustrating here first in this diagram. Again, from the vantage point of space, looking straight down, no matter where the moon is in its orbit around the Earth, the half of the moon facing the sun is always illuminated. It's always bright. The half of the moon not facing the sun is always dark. It's in darkness. So again, no matter where the moon is as it's going around the Earth, the side facing the sun is lit, the side not facing the sun is dark. And the way you can illustrate that in your notes is simply by shading in the back half of the moon. And when I say the back half, I mean the half of the moon in darkness, not facing the sun. So if the sun is over on the left, then you're going to be coloring in with your pencil the right hand half of each of these moons. You'll see how this will tie in just a little while. Okay, so again, this is your vantage point from space. Now imagine you are on the Earth. In fact, you don't even have to imagine that because hopefully you are on planet Earth. And from our vantage point on Earth, when we look up in the sky and we look at the moon, depending upon what time of the month it is, we're either looking in this direction or looking in this direction, regardless of what the day and the time is. We're going to be looking in the direction of wherever the moon is. So if the moon is in position number 1, which is called a new moon, and we're here on Earth and we're looking up at the moon, we're only going to be seeing the dark side of the moon. We're not going to be able to see the illuminated side because we can't see through the moon. The moon is not transparent. We're only going to be seeing the side of the moon that is facing us. Likewise, if the moon is over here in position number 5 and we look at the moon from planet Earth, we're only going to be seeing the completely illuminated side of the moon. We're not going to see the dark side of the moon. So we'll see a completely illuminated disk. So here's what I'm going to ask you to do. We're going to go through the 8 different phases of the moon, and over on the right-hand side of your page, you've got the view from Earth. You're going to be shading in view from Earth in the appropriate manner, and you're going to be labeling what phase it is. So let's begin with position number 1. Position number 1 is the new moon. Again, this is when the moon is positioned between the Earth and the sun, and all we're looking at is the shadow of the moon. We can't see the surface of the moon because, well, the sun is shining on the opposite side. It's also during this new moon phase when the moon is closest to the sun, which means it's out during the middle of the day, and you would be blinded trying to look for the moon during a new moon because, well, unless a solar eclipse is taking place, the sun is way too bright for us to see. So in your space next to number 1, you can color in the entire circle of the moon to represent the fact that it's all shaded. That's the new moon. Let's go to phase number 2. This is called the waxing crescent. Wax on, wax off. That's a reference to a famous movie long ago. The waxing crescent. Now, keep in mind that when you wax something, like if you're waxing a car, it should get brighter and brighter because it's reflecting more sunlight. Likewise with the moon. The waxing phases of the moon means it's getting brighter and brighter. So as we go from the new moon to the waxing crescent, it looks like a giant fingernail in space. We only are seeing from our Earth's vantage point, we're only seeing a crescent shape. And the crescent shape begins on the right-hand side of the moon. And think about that in terms of the diagram from the perspective of space as it is moving. The rest of the moon, however, is still in the shadow of the moon and we can't see it. Keep in mind, as we go through these phases, the reality of the matter is the moon is always half lit. But at this point in time, we are seeing the crescent, the waxing crescent phase. As it continues to spin on its axis, we see more and more of the moon. Here is the first quarter phase. During the first quarter phase, we actually are able to see 1/4 of the moon. Remember, the moon is a sphere. when you can see half of the moon, and we'll get to that in a little while, that's 50% of the moon. Well, at this phase, and I'm going to tilt it on its axis like this, at this phase, we're only seeing 1/4 of the moon illuminated here. That's why we call it the first quarter phase. But let's continue. Here's the waxing gibbous. Remember waxing? It's getting brighter. It's getting closer to full moon. The waxing gibbous, the word gibbous just means it's almost a circle, but not quite yet. So we're getting closer until we get to the full moon. And with the full moon, we are seeing not the full moon, but we're actually seeing a half a moon. We're seeing the half of the moon fully illuminated, the side that is pointed directly at the sun. Now, when we look at a full moon, different cultures around the world actually see different things. Some cultures in the world actually see the man in the moon. Here's an eye here, and a big eye here, and a mouth here. It's like a strange face that you might see on a snowman. But many people see the man in the moon. Some cultures, and I never saw this until I married my wife, because my wife is a bunny lover. And my wife sees the bunny on the moon. And now, anytime I look at the moon, I always see the bunny on the moon, not the man on the moon. Now, if you don't see the bunny yet, let me illustrate it for you. Can you see it now? Here we have the body of the bunny, the bushy tail of the bunny, and the ears of the bunny, and the legs of the bunny, and the bunny's looking straight up into space. But go back. Can you see the bunny in the moon now? I always see the bunny in the moon anymore. So the full moon, different cultures see different things. I now see a bunny in the moon. Let's get back to the full moon and our phases and continue with the remainder. Next, the gibbous phase, once again, it's like almost a full circle, but it ain't. But instead of a waxing phase, we now put the prefix waning. The word waning means, well, getting less bright, kind of settling down. When things wane, when things wax and wane, they go up to a climax and then start going back down again. We are now waning, getting less bright. This is the waning gibbous. So you can be coloring in just a crescent on the right-hand side of the moon. That brings us to the last quarter phase of the moon, when we can see the other quarter side of the moon illuminated. And then finally, the waning crescent. This looks like a big fingernail or toenail in the opposite direction as we wane and get darker and darker until we eventually go back to the original starting point, which is the new moon again. And it repeats in the same pattern every month, month after month, year after year, century after century. We've got the moon continuously going around the earth, and we see the different phases over and over and over again. Now, in your book, this is what it should look like. Here are the phases of the moon, starting with the new moon, the waxing crescent, the first quarter, the waxing gibbous, the full moon, the waning gibbous, the last quarter, and the waning crescent moon. And notice how all of our moon circles have half of it illuminated, half of it in darkness. No matter where it is, when the sun is shining, it's illuminating the side facing the moon. So there we have it. Those are the phases of the moon. As I said, there's a great video that I'm going to show you that really illustrates this well. But now you have it in your notes as we move on to other influences that the moon has on our planet, namely the tides on Earth. This is potentially the biggest impact that the moon has on our planet and its impact on lots and lots of life forms. So, how many of you have ever been to the beach? And how many of you have ever been at the beach for an entire day? How many of you have ever been at the beach during an entire day and noticed that the water level either is rising or receding? And either you want to move closer to the water or you want to move farther away from the water so your towel doesn't get wet. Yeah, I used to live on the beach. I love the beach. And so I'm pretty familiar with this rise and fall of the oceans due to the moon's pull. So let's look at this diagram for a moment, and you'll see planet Earth is the darker blue sphere. And Earth rotates on its axis once every 24 hours, once every day. It's going through a rotation on its axis. But at the same time, as we know, the moon is also revolving around the Earth. And at different times of day and different times of the month, that relationship between your position on the Earth and the moon's position relative to the Earth, we experience different tidal influences. Now, in this diagram again, here's the Earth, here's the moon. We're viewing it from the top view, let's say. Lighter blue color here is representing an exaggerated view of the oceans. You see, the moon is a pretty massive object. Not as massive as the Earth, but pretty massive nonetheless. And so it exerts a gravitational force on the Earth and everything on the Earth, including the oceans. So the oceans, because they're fluid and more flexible than the Earth itself, the oceans are pulled in the direction of the moon. But we get this bulge on the opposite side of the Earth as well because water seeks its own level, and the Earth is also being tugged a little bit by the moon. So as a result, as the Earth spins on its axis, if we were located right at the tip of this arrow on the Earth, oops, I didn't mean to do that. But if we were located right on the tip of the Earth here, at this point, we would experience a high tide if we were near the seashore. We'd see high tide. But 6 hours later, we would be over here and notice a low tide. 6 hours later, we'd see a high tide again. 6 hours later, we'd see a low tide. And 6 hours again, approximately, we'd be back at high tide. Basically, there are 2 high tides and 2 low tides in the course of one Earth day. Now, it's not exactly that because we're also moving around the sun and the Earth is moving around, or the moon is moving around the Earth. And so there's about a 50-minute lag period every day. So there's a change in the time of the tides every day of about 50 minutes, depending upon where you are. But this basically describes the tides on the Earth on a daily basis. But there are also 2 different kinds of tides depending upon the phase of the moon. Let me explain. In this diagram here, we have the sun, the Earth, and the moon lined up. When we have an alignment of the sun, the Earth, and the moon, which takes place either at the full moon or the new moon, the tides are more extreme because of the combined gravitational influence of the sun, the Earth, and the moon all being in the same direction. We call those kinds of tides, whether high or low, spring tides. Spring tides are more extreme because of the combined gravitational influence. However, during the first quarter or the last quarter, when the moon is perpendicular to the line that joins the sun and the earth, well, the tides are less extreme, and we call those neap tides. So spring tides are more extreme because of gravity. Neap tides are less extreme because of gravity. It all depends on the position that the Earth and the moon are in. And speaking of those positions, we're going to finish with eclipses. Eclipses are probably the most dramatic thing that we can observe based on the relationship of the position of the Earth and the moon. Very dramatic. Doesn't really influence us much physically, but emotionally, it has a major impact on us. An eclipse, in general terms, is when one object passes into the shadow of another. And here on Earth, we get to experience two different kinds of eclipses: a lunar eclipse and a solar eclipse. So let me demonstrate with a couple different diagrams. Then tomorrow's activity, you're going to experience this in real life in the laboratory. So let's begin with the lunar eclipse. A lunar eclipse is generally less dramatic, and it's more visible to everybody on the Earth if it's nighttime for you. Because here's what happens with a lunar eclipse. During a lunar eclipse, the moon, that's what lunar refers to, the moon enters the shadow of the Earth. Now, there's two different kinds of shadows. There's the penumbra and the umbra. The umbra is the smaller, more focused shadow of a body in space, in this case, the Earth. And the penumbra is the larger shadow. We'll play around with this tomorrow in the lab. When the moon travels directly into the umbra, the darker shadow of the Earth, something really cool happens. The light from the sun refracts through the Earth's atmosphere, and only the red light shines on the moon. Many lunar eclipses look otherworldly because the moon turns red or orange or rusty color. Depends on how the Earth's atmosphere is at that point in time. But it's not uncommon that a lunar eclipse, which can last hours as it travels through the large shadow of the Earth, can look blood red in color and can be very ominous. Now, a lunar eclipse only happens during a full moon phase of the moon. So it can be pretty dramatic when you are expecting to see a full moon and you look up and you see a full moon that's dark red in color. It can be pretty freaky if you don't know what's happening. But probably the most dramatic eclipse here on Earth is a total eclipse, not of the heart, but of the sun. A total eclipse of the sun. And here's what happens during a total solar eclipse. A total solar eclipse is when the sun itself is eclipsed by the moon, by the tiny little shadow of the moon. Since the moon is so much smaller than the Earth, its umbra, its darker shadow, is barely a pinpoint of shadow, complete darkness on the surface of the Earth. More of the Earth experiences the penumbra, and much of the Earth experiences nothing at all. A solar eclipse, by the way, can only happen during a new moon phase. But if you are fortunate enough to be in the umbra of the moon, that pinpoint location on the Earth, then this is what you see in the middle of the day. Typically, a solar eclipse will happen midday when the sun is completely bright, and then all of a sudden, within minutes, it's completely dark. It can look as dark as nighttime in the middle of the day, and you'll see this very strange ring around the moon, which is actually the corona of the sun. We'll learn more about that when we get to the astronomy unit this year. But talk about a dramatic eclipse. Goes from a beautiful midday sunny day to complete darkness in a matter of minutes. You see, solar eclipses only last minutes, not hours. In fact, sometimes they could last only seconds before the sun starts to come out of the shadow of the moon because the shadow is so small. But a very dramatic thing. I'll show you some videos and pictures of both solar and lunar eclipses. I'll put them into the lesson later on so that you can see just how dramatic they are. Now, just a few years ago, we had a total eclipse of the sun in the United States, and it could be seen from the Pacific Ocean to the Atlantic Ocean. It was called the Great American Eclipse. And people all across the country literally could see the solar eclipse, and it was pretty cool. But you can go online and check and see when the next solar eclipse is going to be. Here's the one I'm looking forward to. I think it says April 8th, 2024, if I read that correctly. That's the one I'm looking forward to because I plan to take my wife on a trip to Niagara Falls right here on Lake Erie and watch the total eclipse of the sun in the middle of the day at Niagara Falls. I think that would be a really cool location to see a total solar eclipse. But here's the path of that one I made reference to in 2017. Here's another one in 2045. I don't know if I'll be around. You folks will probably be around then, but that's going to be another huge eclipse all the way across the entire country. You can also go online and check out the timing of the next lunar eclipse as well. These are predictable. They are mathematically calculated because we know the orbit of the Earth and we know the orbit of the moon. You can predict with very good accuracy exactly when lunar eclipses and solar eclipses will take place. But years ago, people had no idea when these things were going to happen. And so when they did happen, golly, they had no explanation at all. Today we have explanations, but they're still really cool to look at. So I'm going to call it quits there, and I'm going to fade out to complete darkness here in a moment as I bid you adieu and read up for our lab activity tomorrow as I say bye-bye.